Okay. All right, so hopefully I'm recording now. At 6 a.m., the temperature was -4 degrees Fahrenheit. By noon, the temperature had increased 12 degrees. What was the temperature at noon? So we're going to start. Y'all are welcome to say something. Okay, so -4 degrees is where we start. And then it's increased by 12, so that would be a plus 12. So what is our answer? What is it at noon? It's on the board, guys. What's -4 plus 12?
9.
8.
8 degrees. Okay, so it's increased to 8 degrees Fahrenheit by, and so this should go on your sheet. You should put all the work on your little sheet there. Okay, the ratio of the length to the width of a rectangular field is 3 to 2. Now, a lot of you had trouble with this, so let's look at this. Okay, so the ratio, here's the length, and here's the width. Okay, and the ratio length to width is 3 to 2. We use the little colons there to indicate ratio. Okay, and then it says if the field is 120 yards long, so 120 is its real measure. Okay, if the ratio is 3 to 2, then what is this one going to be over here? What is the width of the field going to be? Okay, so we can do this several ways. We can take the 120 and divide it by 3 to see what the multiple is, what the scale factor is. Okay, so 120 divided by 3 is 40, and 2 times 40 is 80. So that's one way that we can do it. Okay, the other way is we can set up a proportion. 3 is to 2, so that's length is to width, as 120 is to something. We can put an X there, and we can set it up as a proportion. And once it's a proportion, we can what? Cross multiply. And we can say 3x is, what's 120 times 2? Okay, 120 times 2 would be 240, right?
Yes.
So 3x is 240. 3x is 240.
It looks like you put 248.
And then, yeah, it does. This thing is so hard to write on. And then 240 divided by 3 is what? 80. So either way you want to set that up, either using a scale factor like I did here, 3 times 40, so 2 times 40, or using a proportion like I did there. Okay, any questions on that one?
What is this?
What is what? This is the 7A. That's a pre-test for your test on Monday. So we're going through. You need to move up, hon. Why don't you move up? Sit up there and let's see. Okay, so these are 2 things that need to go back in that go home papers. They're not here. Okay, so, all right. Can you see Alexa if she's that? Okay, all right. So now,
Can you move your like that way? I can see. Yeah. Okay.
why did you sit? Well, just you've got to stay out of her way, okay? All right, so here, the table shows the results of a 100-meter race, including the time in seconds for the first 3 finishers. The first place finisher ran how much faster than the second place finisher? Okay, so remember, the faster they run, the lower their time, right? And so it says the first place is compared with the second place. So all we're going to do is say second place was 14 seconds and 0.02. And then the next one was 13.89. And we're going to subtract them. Okay, so when we do that,
You put
12, that's going to be,
mistake.
oh, did I do something wrong? Oops, I did. That's supposed to be a 9. Sorry. 9. Okay, so 12, we're going to go way over here, make this a 3, make this a 9, make this a 1. Okay, 12 minus 9 is 3. 1 point, and then everything else is 0. So it's 0.13 seconds. Okay, some of you just put 13, and that's not the same thing as 0.13. Okay, at $2.249 per gallon for regular gasoline, what is the cost to the nearest cent of 9.1 gallons? Okay, so if we're paying 2.249, everybody should be doing it on your paper. You don't need to wait for me to take 20 years to write this thing. Okay, do it on your paper and see if you get it right. Okay, so now I got to add all that together, and I think I'm out of space, but let's see if I can still write down. Nope, I can't write down there.
Did we already do this?
Yes, we already did this. We did this as a quiz in class. And you already have that, but we're doing the clean sheet now because I want everybody to have the right answers. Okay.
20.469.
Okay, so now we have to round that to the nearest cent. So the nearest cent is right here, isn't it? All right, 2 digits would be cents. So this 5 has got to round up. So we're going to make this turn into a 7. So we're going to have $20.47, excuse me, $20.47 is our final answer. Any questions on that one? Okay, for the questions 5 and 6, refer to this spinner divided into 3 congruent sectors. If the spinner is spun twice, what is the sample space of the experiment? Okay, so we're going to say spun twice sample space. So we could have A. In other words, 2 separate spins, we could get an A on both spins. So when I do these, I like to keep all the first the same to start with. We could have AB. We could have AC, right? Okay, then we're going to change the A on the first one to a B. The first spin could be a B. And if it was a B, then the second spin could be an A or a B or a C, right? So we could have BB, BC. And then lastly, the first spin could be a C. So we'd have a C and a C and a C. I'm going to try to fit them in a column. And then we would have CA, CB, CC. So a sample space is just a systematic way that you're going and writing all of these. Are you writing all these notes down, Logan? All of these are supposed to go home with you as notes on this little empty test that I gave you. So you're supposed to be writing everything I'm writing, guys. Everything. This is your review sheet. Okay? So, does anybody have any question on how to write a sample space? You're looking at all the different ways you could have a first spin and a second spin. Okay, so
we write all these down to interest.
yes, so basically that is your sample space right there. That is number 5's answer. Okay? So now, so when you have 2, so basically we had 3 options, A, B, and C, and we end up with 9 answers. What? So basically we had 3 ways to do the first one. We had 3 ways to do the second spin. What's 3 times 3? 9. That's how many options you should have in your sample space. Okay? So, oh, did I get coffee this morning?
Daughter did that, even though she got one herself.
Why did you?
She's.
Oh.
He got the.
Oh, honey, thank you. She's so amazing. All right. Okay, everybody understand. So now, the second part, number 6 says, if the spinner is spun twice, what is the probability that the spinner will stop in sector A at least once? So we're looking for every option up here that has an A in it. Okay, so let's get our something like yellow here, so that's easy. So this one has an A, this one has an A, this one has an A. I'm highlighting, not crossing out. This one has an A, and this one has an A, doesn't it? Okay, so we have 5 options out of how many options?
9.
Out of 9 options. So we're going to say 5 out of 9, or 5/9 is the probability that we're going to spin an A at least once. Okay, do you understand why you cannot do the probability without the sample space? Okay, a lot of you were just, throwing things out there. Okay, Lily, are you copying down all of these, sweetie? Okay, because I know that almost everybody missed that. Do we have any questions on that now? Zia, do you understand how we get the sample space and how we get the probability? Okay.
That makes more sense now.
All right, good. All right, so a door handle turns from position A to position B. This is an example of rotation. Okay, the mean distance from a Venus to the sun is about 1.08 times 10 to the 8th kilometers. Write that number in standard form. Okay, so we're going to have 1.08, but then we're going to take and move 8 steps to the right, aren't we? So this decimal, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now we're going to fill in with the zeros. Now, everybody, when you leave your final answer, you're not going to leave it like that. That's your work to get to the answer. So let's take the answer and now rig it up correctly. Okay, so I'm going to have 0, 0, 0, comma. Okay, so I wrote that. That's going to be a comma there. That's going to be a comma there. So 0, 0, 0, comma, 1, 0, 8. Does everybody understand that if you do not rewrite your answer with commas and take out the decimal and all your little work things, you're not going to get it right? Okay? Because when we leave it in standard form, we don't leave all of the decimal and everything else in there. Okay? So you must interpret the answer correctly for your poor teacher. For questions 9 and 10, refer to the rectangle. 2.14 inches times 1.14 inches. What is the perimeter? So perimeter is the distance around. That means this one right here is also 2 1/4. Okay? And this one over here is also 1 1/2. Okay, so let's do this by the opposite sides. 2 1/4 plus 2 1/4 would be what?
4 and
2 1/4 doubled. Okay, and then we're going to have 1 1/2 doubled, right? And that's going to give us 4 1/2 plus 2 times 1 1/2 is 3. And 4 1/2 plus 3 is 7 1/2. Got it? Okay. So now, okay, I'm going to come back to it. Okay. The perimeter. So basically, what is the area? Okay, so let's go back to our figure. What is the area now? We're doing number 10. What is the area? Now we're going to have to take 2 1/4 and 1 1/2 and multiply them together. Okay, so 2 1/4 and 1 1/2 multiplied together. Now, we don't multiply mixed numbers together like that, do we? What do we do when we're multiplying mixed numbers?
improper fractions.
Improper fractions. What's the improper fraction for 2 1/4?
9/4.
9/4 times what is the improper fraction for
3 halves.
3 halves? So now there's nothing that's going to cancel to make that any better, is it? So we're going to have 27/8, and then we're going to put that back into, so we're 27/8 would be what? How many times would 8 go into 27?
3 and 4/8.
Okay, so 3 and 3/8, right? 27, 24, 3.
Yes, right.
Okay, 3 and 3/8. Does everybody agree?
Sure.
3 and 3/8. Do you understand? Does anybody need any more copy time on that?
Go back to the other side.
Okay. All right, so the next one that we're going to do is number 11. Are we done, Lily? Thank you. Okay, number 11. Write 1/6 as a decimal and as a percent. Now, you're going to have to do this on your test. First of all, 1/6, we're going to divide 1 by 6. We're going to put our little decimal 0 here, right? We're going to do long division. 6 goes into 10 one time, and the decimal is right above the old decimal. 1 times 6 is 6. Subtract, we get 4. Bring down another 0. 6 into 40 goes 6 times. 6 times 6 is 36. And we bring down 4. So that's just going to repeat, bless you. That's just going to repeat, isn't it? So it is 1.16 with the repeating over the 6, isn't it? 0.16 repeating. Okay, so now how am I going to write that as a percent? Okay, remember to write it as a percent, I'm going to take this decimal and I'm going to move it 2 places to the right and stick the percent sign on. Okay, so as a percent, it's going to be 16.6 repeating percent. But we don't usually leave a repeating in a number. Okay, so what are we going to do? 0.6 repeating is going to be the 0.6666. So how would we do that? We would use a remainder instead, right? So we wouldn't change it to a 0.6666. We would say, oh, well, that 4 was a 4 out of 6. Okay, so when I move this over, instead of saying 0.6666, 0.66666 is double 0.33333. It is 2/3. So 16 and 2/3%. Does everybody understand that we don't leave a repeated number in a percent? We change it to a fraction. 4/6 is 2/3. So 16 and 2/3% is the percentage, and 16, what was it? 0.16 repeating was the decimal. Does everybody understand how to do a decimal and a percent and why they look different from each other? For the percent, we write the leftover as a fraction, and you can find that from your 4/6. Okay? Any questions? Use prime factorization to reduce. Oh, I love prime factorization. Okay, so we're going to start with 288. All right, now, just divide by prime numbers, and the easiest one is 2. Okay, so that's going to be 144. And then we're going to divide again by 2. And that's going to be a 72. And we're going to divide again by 2, which is going to give us 36. And we're going to divide, what's that?
That'll give you 12.
Okay, so 2 into 36 is 18. And 18 divided by 2 is 9. And 9 is 3 times 3. Okay, so I'm out of room, but we'll just say, I don't think I can. Well, I can. 3, 3. Okay, so now what are we going to do? 1, 2, 3, 4, 5 2s, so that's 2 to the 5th, times 3 squared. Does everybody understand that? So now we're going to come over here and think of 360. 360. I'm going to put 360 right here so I can come down. 360 divided by 2 is 180. Divided by 2 is 90. I'm going to go ahead and divide by 3 because it's easier. 3 is 30. 3 is 10. And 10 is 2 times 5, right? Okay, so now I'm going to write this right underneath here. So I'm writing this as a fraction. 288 was 2 to the 5th times 3 squared. 360 is 1, 2, 3 2's. Okay, can everybody see? 1, 2, 3 2's, right? So we're going to say 2 to the 3rd times, how many 3's? 3 squared times a 5. Got it? Okay, now we're simplifying it. So can everybody see that we're going to take the 3 squared and the 3 squared and get rid of them? And what's going to happen when we divide the 2 to the 5th by the 2 cubed? What do we have left? Remember, when we multiply, we add the exponents, and when we divide, we subtract the exponents. So 5 take away 3 is 2. We have 2 squared times a 5. All right, now guys, remember, let's look at this. 2 to the 5th is 2. 2, 2, 2, 2. 2 to the 3rd is 2, 2, 2. I want everybody to understand why this works. Cancel. Cancel. 2 squared is left. 5 minus 3 is 2. 2 squared times 5. 2 squared is 4. 4 times 5 is 20. Isn't that cool? Okay, now, 20's on the... Wait. The 5's on the bottom. My bad. I was going, what have I written wrong? The 5 is on the bottom, and that does not show up here. Okay, everybody correct what I just did. The 2 to the squared is on the top, but the 5 is on the bottom, and I just miscopied that. Okay, so we have 4/5. And that makes sense. When you look at the fraction, it's definitely less than 1, isn't it? Okay, did everybody correct that? 4/5 is the answer. Anybody have questions on that? While I get a sip of my coffee.
Can you go back to number 9?
Go back to what?
Number 9.
Number 9? Number 9, okay. Okay, I'm going to post this online too, so you'll be able to go back through and review all of these. Okay? All right. All right, look at number 13. Triangles ABC and DAC are similar. Okay, so let's look at this. A, B, C, and we'll make this a little different. Okay, D, A, C are similar. What does similar triangles mean? What do we know about similar triangles? They have the same angles. So corresponding angles are the same measure, aren't they? Okay, what else do we know? Proportionate sides. So the ratios of the sides to each other would match on each one. Okay, so basically these are similar. It does not say that they're congruent, but we'll be able to look at this. Which side of DAC, so DAC corresponds to AB? So which side is going to correspond to AB? AD, right? AD is the corresponding side. Does everybody see why AD is the corresponding side? Okay, solve by inspection.
7.
Very good. 7 is the answer. Okay. If you take 12 divided by 3 is 4. So 21 divided by 3 is 7. Now, what's another way you could do it?
4 times 3 is 12. 7 times 3 is 21.
Okay, 4 times 3 is 12, 7 times 3 is 21. You could also do your cross multiplication. That would not necessarily be easy in this case. Okay, so in other words, you could do your cross multiplication. 4 times 21 is 12 times x. Okay, but that would probably be harder. Okay, so for questions 15 through 20, simplify the expression.
18.
Really? Really? You can have a debt of $6 and a debt of $12
Oh.
and come out $18 ahead?
Negative 18.
Okay, does everybody see why it's negative 18? All right, what's our rule? Same sign, add, take the common sign. Negative 18. Okay, this one.
Negative 15.
Really?
Negative 3.
Okay, so what are we going to do?
Positive 3.
Thank you. All right, aren't we going to change this minus? We're going to change the minus sign to addition of the opposite, aren't we? So now we're adding opposite signs, which means we subtract. When we add opposites, we subtract. We get a 3. We take the sign of the big guy, which is positive, and the answer is positive 3. Okay, a little bit of order of operations with different denominators. Fun times. Okay, first of all, is there anything that's going to keep us from going left to right? Subtraction and addition are at the same level, aren't they? Okay, so we're going to have to get a common denominator between all of these. Now, we don't have to worry so much about 2 because 2 already goes into 8. So we're going to worry about 8 and 3. What's 8 times 3?
24.
24. So we're going to go to a common denominator of 24. Okay, so 8 times 3 is 24, so 7 times 3 is 21, isn't it? Okay, and what would 1/2 be if we put it over 24? 12? Okay,
Sorry, I'll do it.
12 over 24. And what would be 3 into 24 is 8, so we're going to multiply by 8 over 8, aren't we? So that's going to be 16 over 24. 16 over 24. All right, so now we have the same denominator. We're just going to do the work. 21 take away 12 is what? 21 take away 12 is 9. And 9 plus 16 is 25. So our answer is 25 24ths. Okay, now suppose we're not supposed to leave it as an improper, what would we do?
1 and 1/24.
1 and 1/24. 1 and 1/20. Any questions on that one? All right. Okay, 4.6 minus 1.27. We've got some good decimal action going on here. All right, so we're going to take our numerator and 4.6, and I'm just going to make that 4.60 so that I have enough digits for everything, and a 1.27, because this is where we have to line up our decimals, isn't it? Okay, so we're going to subtract, make this a 5, make this a 10. 10 take away 7 is 3, 5 take away 2 is 3, and 4 take away 1 is 3. So we have 3.33 on the top, okay? Now, on the bottom, what do we wind up with? Now we're multiplying. What's 0.3 times 1.3? Logan, you got an idea?
0.03.
0.03?
Sorry, 9.
Yeah, 0.09. Okay, now why is it 0.09 instead of just 9? We got 2 decimals. Since we have 2 decimals, it's going to move it 2 places to the left. Okay, so this one right here is 0.3 times 0.3, which is 0.09. So we're going to put this right under here, 0.09. Now, I can clear out those decimal places. I can move this 2 places to the right and this one 2 places to the right. So I can just get rid of it. Yes? Okay, so now, yes. So we've got 333 divided by 9. Does everybody see how I could just clear out those decimal places? Multiply the top by 100, multiply the bottom by 100. The decimals are gone. So now 9 into 33 goes 3 times with a 27. And I get a 6 and a 3. 9 into 63 is 7. Even, the answer is 37. Any questions? Okay, number 19, order of operations. What do I do
26.
first? Huh?
My answer is 26.
Your answer is 26. Well, we'll put it up here and see if you're right. Okay, 26. Anybody else got a stab at that one? Okay, so order of operations, we're going to move left to right, but we're going to look and say, do we have something we have to do first? Parentheses. So right here we have parentheses. 4 minus 2 is 2. Okay, so now please excuse, right? Excuse is exponents and roots. So 49 is a root. So 49 is what? 7. Okay, so now this one is also an exponent. 25, right? So we have 25. Take away, and then this is multiplication. So that's a 6. 2 times 3 is 6. Plus a 7, and it certainly looks like the answer is 26, just like Nick said. Any questions on that one? And lastly, we're going to go across the top and go across the bottom. So what is the numerator going to equal? X to the 8th, thank you. When we multiply, we add like bases, and the denominator will be?
X to the second.
Really?
X to the third.
Okay, so that little x, remember, Nick, has a 1 right there, doesn't it? Right? There's always an understood 1 if you don't see an exponent. So we've got an x cubed on the bottom. When we divide, we subtract exponents, so our final answer is?
X to the 5th.
X to the 5th. Any questions on that one? And we have thoroughly reviewed for our test. Okay, so this video is going to be posted online for you. We have this test on Monday. Any questions?